multiple threads, right? Yes, multiple threads only will use it. If single thread means will not come to know, right? Directly it will execute that. If two threads is trying to access same method, in that case we need to will come to know the synchronization concept. Let me. Are you able to see my screen? Yeah. So synchronization. Yeah. So either single thread we can create of same class with multiple threads. You mean that you want to create of some other thread once again, one more thread? Even this is also fine. Or we are trying to create of two threads. My thread of T1, this is one thread, and my thread of T2, this is some other thread again. Okay. So, but we are passing off. Let's take, we'll go to the example only. Okay. What is the name that I have given? Sync test. Any sync test? Yes. What I am doing here, I have written one class. Inside it, there is one method is there, right? So if I am not using of synchronized keyword for this method, so that means that at a time, multiple threads also can access this method. Is it clear up to this? If you're not using synchronized keyword, so at a time, two threads can access this method. Okay. So let's say one thread is started its execution. So only two times it is completed. Only two iterations out of what is the for loop? It is a 5 times, right? First thread is started its work and it is executed. It's not fully completed. It's not fully completed its work. Only two times out of 5 iterations. Only two iterations is finished. Rest of three is still pending, and thread 1 is stopped its execution and it is giving chance to other thread which is in waiting mode. Okay, we'll go and see through examples and then run it. Okay, now this is a non-synchronized method, so I'm calling this method in threads. I'm calling that method in thread. This is of, let's say this is my thread. I'm creating of object of display class and some name. Okay, and this is of creating of constructor. Creating of constructor for my thread class. I'm passing of display class object as well as some name. These are dynamic values. And inside run method, after creating of object, so object is ready for display class. Through this object, inside the display class, we have a method called greet method. So I'm calling that method in the thread, in the run method. Okay. Now, if two threads are started means two threads will run their own run method, right? That time, two times the greet method will be called internally, two threads. Okay. Now let's what I am doing, display one. I created one object, display of two of one more object I have created. Okay. Let's comment that one and pass same object for both. Pass same object. So both threads are trying to call off greet method in the display class. Both methods are trying to call off same method, T1 thread and T2 thread. Both threads are trying to call off greet method in the display class object. Okay. Now that time, if the method is the greet method is not synchronized, whichever the two threads are calling of that greet method, okay, non-synchronized method. Okay, if that is not synchronized, so partially T1 is executed and it is giving chance to T2 thread. Okay, and T2 also partially executed and it is giving chance to again back to T1 thread. Again T1 will start executing from the third iteration. Third and fourth is completed and still fifth is pending. And again T1 is stopped its execution and it is giving chance to T2 thread again. So T2 is also like that. It is sharing of the method in between. It's not fully completing, any of the threads is not completing their work fully. Okay, so that time we will get of irrelevant result, irregular output. Let's see, T2 is started, T1 is started. The output is both are simultaneously executing for some time. Congratulations, no name is printed. Congratulations, J, it is of first thread. Okay, or else let me print of thread name also. Name of the thread. Let's do this system.out.println of thread dot current thread dot get name. Okay, I'm executing of some name also. Right, a thread one. It is of executing that time. 1 second. Not out. Let copy that code. Alex. Let's try. See thread one. Again, in between it is giving chance to thread. See, congratulations, thread 0. And thread 1 it is giving chance again. 2 times thread 1 is executed. And again it is giving chance to thread 0. Again it is giving chance to thread 1. Like that it is not finishing both the threads. None of the threads is not finishing their work completely. It is sharing of the lock. It is a sharing the method. Sometimes thread 1 is taking, sometimes thread 2 is taking. So in that time, we are not getting the output as correctly. Okay. Now let's say if I am making this as synchronized, that's why synchronized. Now let's see. Okay, just added only synchronized. Let's say if the T1 is started or T2 is started, doesn't matter. Whichever is taking the lock first, whichever is started this method execution first, that will not give lock to other thread until it is finishing their work. Let's run it. Thread 1 is taken. Okay, and it will not give chance to thread 2 until thread 1 is finishing its work. See, can please go on mute whoever is not speaking, please. Deepali, can you please? Imran, is it clear? The method is not synchronized and two threads are trying to access same method. Okay, in that case, so it is going to check whichever thread is taking first access, whichever thread is started the execution first. So it will not give or it will not release the lock for other threads to execute of this method. Okay, once T1 is started, then this method will be locked. It will not give chance to execute of any other threads until finishing of its task. Clear, Imran? Or yeah. Now, yeah, I think someone asked one more question on yesterday. Yeah, you can ask me, guys. Is that you only, Imran? Okay. Okay. If no doubts, then let me start off. Today the new topic is again. Let's go and check. Not new topic inside multi-threading only. The topic is deadlock. Deadlock. What is mean by deadlock? Deadlock means, let's say, two threads are trying. Okay, two threads are trying to access same resources again. Two threads are trying to access same resources. Okay, now we'll take off some example. Let's see. Yeah. So two threads is there. Okay, T1 thread is trying to access of T1 thread is there is some work with T2. Okay, if T2 is releasing of lock, then T1 can utilize it. Okay, and again T2 is also trying to, if T1 is holding the lock, T1 is T2 is trying to release the lock. If that is released, then it can continue of T2 thread work. Let's go to diagrammatically paint. Let's take off thread 1 is of T1. Okay, and let's take off one more thread T2, and it is of T2 thread. Okay, and there is some resource is there. It is of some resource. Just assume there is some method or something. Okay, resource, anything we'll call it as a resource. Okay, now T1 is started its execution. T1 is started its execution, and it is executing in between, and it is executing this T2 resource. Okay, so this resource is under execution, and while executing it, so already this resource is under the execution of T2 also, under the execution of T2. Okay, now what it will do, T2 is trying to release the lock of T1, and T1 is waiting for the to release of lock of T2. Okay, both will be in the never ending state, both will not release their lock. Okay, in that case deadlock will come into the picture. So both will never, T1 thread will not release the lock, and T2 also will not release the lock. Okay, in that case both will be in the waiting state. Okay, that situation will call it as a deadlock. Now we'll take one example also. See, deadlock is a condition which occurs when two or more threads get blocked, get blocked or in the waiting state, waiting for each other. T1 is waiting for T2, and T2 is waiting for T1 to release off their locks. Okay, waiting for each other for an infinite period of time to release the resources, that they hold. Already they are holding up some resources. Okay, so both are trying to access same, but both will never release the locks. Okay, these both threads will be in the never ending, both will never release the locks. So it is of thinking like, yeah, T2 will release the lock, so T1 is thinking T2 will release the lock, I can complete my work, and T2 is also thinking T1 will release the lock, so I can continue of my execution. So like that both will thread will be in the like that it will in the waiting mode, but both threads will never release the lock. That situation will call it as a deadlock. Deadlock is a common problem in multi-threading programming. Deadlock is a common issue or common problem in multi-threaded programming, which can completely stop the execution of your application. Okay, so if deadlock is occurred in the application, means the application will not run. It will stop the application. Okay, it will stop the application. So there is no resolution technique for deadlock, but there are some preventing techniques. There are some preventing techniques that are we can use. Okay, are possible. The synchronized keyword is the cause for deadlock. Synchronization is a cause. Because of this only deadlock will occur. Okay, if synchronized keyword we are using means if one thread is started execution means it will not give chance to other thread. Okay, so that is in the, it will not, so some other thread is waiting for that lock which is already locked by some other thread. So because of synchronized keyword only deadlock will happen. Okay, whenever we are using synchronized concept, we should be taking care bit careful. Okay, because of this only deadlocks will occur. Okay, now let's take off some example. Because of common resources only, if common resource is trying to shared by multiple threads, okay, that too by using synchronized keyword, then the deadlock will occur. Okay, now let's take off some example. Now let's take off one shared class. Okay, it has two methods. Let's take off class shared. Let's copy paste it. So what I'm doing here, so I have created a one class. Okay, both are synchronized methods. Both are synchronized methods. M1 method, it is taking of object of shared class. Same class object I am taking. And M2 method is also, method 2 is also taking shared class object. Okay. Now this is one class. Next, we'll create of some threads. We'll create of some threads. Deadlock. Deadlock test class deadlock test. Deadlock test. So yeah, now what I am doing here, I have created of two objects. Shared S1, shared S1 equal to new shared S2 equal to new S2. Sorry, new shared. So I have created of two shared objects. Okay, and I have created of two threads also. Thread T1 equal to new thread of running overriding of run method. Inside this S1 dot method 1 of S2. Okay, this method 1 is available in the shared. Okay, and I am passing of one object. It is also a shared object. Okay, and again I have created of one more thread. That thread also calling of from s2 shared s2 object, s2 dot method 2 of s1, s2 of method 2 of s1 object I am passing. Okay, now inside this C, method 1 is calling method 2 and method 2 is calling method 1. Okay, now both the threads are started. T1 is started and T2 is started. T1, this is the thread. Internal it is calling of M1 method. Method 1. In method 1, we are calling again method 2. Method 2 is calling by otherly already T2 thread is calling. T2 thread is calling of method 2 of shared object. Right. So that already taken by T2 thread. The object of that one S2 is already taken by T2 thread. So internally method 2 is again calling of method 1. That method 1 is already, it is execute under execution of T1 thread. Okay, method 2 is waiting, method 2 or T2 is waiting for T1 to release the lock of method 1. Method 1 is under execution of T1 and method 2 is under execution of T2. Okay, and method 1 is internally it is calling of T2. So that method 2 is under execution of T2 thread again, all under execution. Okay, now let's run it. See, T1 thread is calling method 2 and thread 1 is calling method 1. Okay, T0 means thread 0. This thread 0 means it is the first thread. T1 is calling of method 2. Where let's see, this is where it is available. See, it is of method, this one is calling of method 2. Method 1 is calling method 2 and method inside method 2 it is calling of method 1. Both are in the waiting state. Still see, it is of it is not terminated. Both will be in the never ending period, will be in the waiting state only. Okay, we are calling created two threads, so we are calling of s1 of method 1. So s1 method 1 is under execution of t1 thread and method 2 is under execution of t2 thread. Okay, internally these methods are calling each other, so both are under locking by separate threads. They won't release the locks. In that case the deadlock will rise. Deadlock will rise that. Now let's stop it. Let's stop it. See, yeah, this is the one. Let's take it off another example also. Let's take off another example. One more. I have taken off class A of I have taken off method 1 of with synchronized. It is taking off two objects, 2 B and A class. A class is having method 1 and B class is also having method 2 and both are having passing as A and B objects. A and B objects. This method 1 is calling of B class print method. Method 1 is calling of B class print method. B class also having some print method. A class is also having some print method. Now method 2 is calling of A class print method. Method 2 is calling A class print method, and method 1 is calling B class print method. Both all are synchronized methods. Okay. Now let's have another example, guys. Okay. Let's same way. There is no new thing here. I created of A class object and B class object. So for T1 thread, I'm passing internally A dot method 1 of B comma A. This is of T1 thread, and I created of one more thread T2. Okay. Thread T2 equal new thread of run method inside B dot method 2 of A comma B. I'm passing A comma B. I'm passing. So both threads are started. Both threads were started. Internally, the B class thread is B class method object is holded by T2, and A class object is holded by T1. Okay. Internally, this method 1 is of thread 1 internally. Method 1 internally it is calling of B class method. See, it is calling of B class method B dot print. So this object B class object is already under the lock of T2. So it will not give chance to any other thread. It will not give chance to any other thread. In the same way, T2 is also started its execution of method 2. Okay. While executing, so it is calling of A class print method. A class print method. A class object is already under the locked by T1 thread. It will not give chance to execute of print method to execute of T2 thread. Then in that case also, both the threads will be in the waiting state. Both the threads will be in the waiting state. Okay. Now if you want, let's take off. The example is same. Okay. Internally two threads are calling each other internally. Okay. Some other synchronized methods. Okay. If synchronized means already that object will be locked by the thread. Okay. It will not give chance to call off any other synchronized methods in that object. Okay. Now let's of this is another example. If you want, you can take up this. Right of class A and right of class B plus B. Now deadlock test 1. Right of second test 1. Deadlock control n class deadlock test 1. Okay. Let's go to A class. So in the A class, we created two synchronized methods. Both are synchronized guys. Okay. And in the B class also, method 2 and print method. Both are synchronized methods. Okay. Now, while creating objects and then calling two threads. So I created of A class object and B class. A class having two synchronized methods and B class also having two synchronized methods. Okay. Now I create a first thread. T1 thread I have created. I am calling from A class object. I am calling from A class object method 1 I am calling, and by passing of B object as well as A object. So why internally method 1 is we are passing of two objects means we are calling of print method of B class. We are calling print method of B class object on B class object. Next thread 2 is also created. Okay. From B class, this I am passing method 2 from B class object. I am passing of A and B. Internally method 2 is also calling A class object of A class method print method. Okay. A class is already under the execution of T1. Okay. both will never release the lock. Both will never release the lock. Okay. Public. Public type has to define its own type. Yeah. Yes. Now let's run it. See, T2 thread started. Yeah. Thread 2 is started method 2 execution, and thread 1 is started method 1 execution. Okay. Both are started its execution, and thread 2 is trying to call a class print method, a dot print method. That a object is under the execution of thread 1. Okay. And thread 1 is trying to call of b dot print method. That b object is under the usage of thread 2. So both will never release the logs. See, it is under red mode, means it is not terminated. Okay. So then in that case, it will be both objects, both the threads will never release the lock. Both will be under waiting mode only. Both will be infinite period of time. It will be in the waiting mode only. Okay. Now let's stop it. Now there is some prevention way of it's not resolution, guys. Prevention. Okay. It is of prevention only, not of resolution. We can stop of giving the deadlock. So that by using of synchronized blocks. We are having synchronized blocks. See, so both the threads I am passing, both objects I am passing in the method 1. Okay, synchronized of A, and internally it is waiting for some time, synchronized of B. Synchronized of B. Already it is locked. Okay, if already that one is also locked, synchronized of B. Both the order of synchronization must be same. Here also in the method 1 also synchronized of first A block, A, and synchronized of B. Even in the method 2 also give same order. Give synchronized of A and synchronized of B. Then in that case, that prevention deadlock will can be avoided. Now let's copy paste of this part. Will not do anything. Just replace that code. Let's replace of this code. Let's what I'm doing, synchronized is removed. Instead of method making the synchronized method, I'm making only the block. I'm making synchronized block. Okay. Now let's copy paste of B also. Remove of that synchronized methods and call of export is, this is one, this is method, this is class. Now let's go to thread log. Sorry, print method is also missed. Let's call off print method also. Okay. Now deadlock code. So inside this, while passing here, give of that order. Okay. Let it be whatever. While executing, it must be of the some order. Okay. Now let's see. I'll explain it again. 1 second. It is under the execution. See, see it is stopped, both are executed successfully. Okay, now how it is happened means, now in the method 1, so I'm calling of I'm passing two objects, so I'm calling b class print method and a class method 1, right? So first I have started off locking of a method. If the order of locking of objects, if order of locking object is in the same order in the both the object, both the synchronized methods, both in the methods, then there is there is a no chance, there is a less chance of rising the deadlock. In the b class also, synchronized of a and synchronized of b, if you are following of same order, synchronized of a and synchronized of b, then the deadlock will not. In this code, I didn't modify anything, guys. That is same. If I am giving as b first and here as a, okay, then the order is modified. Now let's see, the deadlock will rise. Deadlock will rise. See, it is trying to call off b class print method, and thread 2 is calling off a class print method. Both are in the locked already. Thread 1 is locked off a object, and thread 2 is locked off b object. Both will now never release that. So that is the reason. If the order of locking is, if order of synchronized blocks is in the same order, okay, then the chance of rising of deadlock is less. Okay. Here also it is a BA, and let's make it B and A. Normally A class object we are calling, right? It should be of A and B order. See, if the order is both, it may be A or B or B or A. If one method is following of B and A, then next method also should follow of B and A. Then that is one way of reducing or prevention of deadlock. Okay, guys. Now that's what I have explained in this one. Okay, the prevention of deadlock. Next, next concept is inter-thread communication. How exactly the threads will communicate with each other? Inter-thread communication. These methods are wait, notify, notify all. Wait, notify, notify. These three methods can be used to communicate. Used to communicate threads. Okay, used to communicate with one thread with another thread. Okay, let's two threads are communicating with each other by using of wait, notify, notify all. The thread which is expecting updation, the thread, let's say, yeah, if I am expecting of some update from different thread, if I am expecting some update from different thread, then I'll be in the waiting mode until that is updating me. Until some other thread is giving updation to me, I'll be in the waiting mode. I'll call off wait method. The thread which is performing updation or doing of calculations for updation, it has to call a notify method. So notify means whichever is in the waiting mode, that will come up in the running mode if you are calling of notify method. Okay, after getting notification, the waiting thread gets started its taking updates from the which is already done by the notified thread. Okay, wait, notify, notify all methods are available in the object class, but not in thread class. These methods are wait, notify, notify all methods is coming from object class. Object class is super class to all the classes in Java. So these methods they made available to every class. It's not related to thread. It is giving some notifications to the threads. If any thread want to go to waiting mode, then we can call off wait method. Okay, if any some other thread is complete their work, and it is giving, if it want to give some notification to the waiting thread, then we can call off notify method. We can call off notify method. Let's take off some example. Let's take off some example, and one more last point read and then we'll go. Once a thread calls notify or notify all method, it releases the lock. Okay, So whichever the holding of, whichever the calling that notify method, so whatever the lock that is available with it, it will release that lock. It will give chance to other threads to start its execution. Notify all, notify means it will give chance to only one thread to start its execution. Okay. Now notify all means it is waking up of all the waiting threads. Whichever is having high priority, that thread will start execution. Okay. Now let's take off some example code. Let's see what it is there inside. I will class thread B is of thread B class. So what it is doing? So thread B is, it is extending of thread and total is 0. Public void run method synchronized of, this means current class object. Child thread started calculation. So what is my work here? I am doing is so I'm calculating of 0 to 100 sum. I'm calculating of 0 to 100 sum. I'm calculating. Okay. At the end, at the end, after finishing of this work, then only I will notify to other thread. Then only I will notify to other thread to print off its work. Right. So without calculating, without summing of all the 0 to 100, if I am giving off the result also, it's no use. It is of irrelevant result, right? Now let's create a object and then start off the run method. Add communication. Let's class is the thread communication, right? Thread communication. Yeah. What is the use of this thread? It is of the use of the task of the thread B is okay, calculating of 0 to 100 sum. Okay, 0 plus 1 plus 2 plus 3 plus like that 100, I want to sum of all 100. Okay, the first task is we need to calculate of this, and then the second task is to notify that. Now let's, so in the main method, okay, I created of object of thread B and B started. Okay, if I'm not writing this block, okay, b dot wait, b dot wait, the first step is it is going to wait for the, it is going to waiting, so the which is getting the output from b thread. So thread, inside the thread, if it is notified, then only it will continue that, it will continue its work. Okay, now let's see without synchronized, without synchronized. Now let's see what is the, see illegal monitor exception. That is in the waiting mode. Don't go for waiting mode. Don't call wait. What is the output? It will come. It is giving of output is 0. What is my work? I want to, what is the task of B? It is going to calculate of, it is going to calculate of 0 to 100. Right? That is the work of thread B. Once its work is finished, then it should notify to thread B. It is calling to this thread again back. Right? So if you are not calling that method, what I am doing, what is my work? So if my work is started and it is not giving up the calculation of 0 to 100 of by thread B, then wait. Okay, if it is giving fully, then print that value. If it is not giving that work, the updation from B thread, then go to the waiting mode. So in that case, keep this wait in the synchronized block of B. Which block? This is a B, is a thread B object. Okay, now inside there it is started of main method, thread calling to wait method. It is calling of wait method. Someone has to notify to this object, someone has to notify this thread B, then only it can continue its work. Now let's see It is giving of 50-50. Total sum of all is 50-50. Now, I am not calling of weight method. If I am not calling of weight method, there is no use. It is giving of 0. Let's try for some other time. It may give off some values. If it is a chance is there, it can sum up some value. Main method thread calling weight method. Okay, and here we stopped it. Okay. Now, if you are not, but that is not correct of printing of total without finishing of the task of thread B. So to finish of task B of thread B, okay, we need to wait. Okay, the main thread has to be in the waiting. Okay, main thread has to be in the, someone has to notify to start its execution back again. Okay, this where yeah, see, this is waiting for someone has to update. Who is going to update? Thread B run method internally. This will notify that. Yes, I have finished my work. Okay, I have finished my work. You can continue your execution. So once it is waiting mode, then there it is notified is calling. Then this thread will again the main thread will get access and then it will start off printing this one. The first point is it has to go to waiting part, and the next second step is it has to calculate of sum of all, and third step is notification to the waiting thread. Okay, and then once it is notified, then it will start off execution of the rest of the part. Okay, if we are calling here, if you are calling here notify all, then all waiting threads, then all waiting threads will be notified. Now in this case only one thread is waiting. Like this, if any multiple threads are waiting, then we can call off notify all. Then in that case all waiting threads will be resumed. So out of all, whichever is having highest priority, okay, highest priority, that thread will get a chance to start its execution. Okay, that's what the thread communication. Okay, tail thread, where is that? Yeah, let's go on if you want. Where is that? Yeah, main method is started. Okay, so in this of events thread is started, and but it is calling of this one, and main method is started and calling of wait method, and it will normally actually this is started, right? Now it is waiting, it is going to, I am not getting update from thread B. That is the reason it is going the waiting state. So the thread which is read it. Yeah, the thread which is expecting update. The thread which is expecting from updation. It has to call wait method. So this one is main thread is expecting some result from B. Right? Waiting from B. So I'm calling of wait B dot wait. So and the thread which is performing calculations or updation, it has to call notify method. So the B object, once it is and started and finishing of its work, then this thread has to call off notify method. Then whichever is in the waiting mode, that will get chance to start its execution back again. That's what here the thread which is performing updation, it has to call notify method. After getting notification, the waiting thread starts its execution again. It will take the updations and it will start continue its work. Okay, that's what the communication inter-thread communication, inter-thread communication. Now next, what is the topic? Thread life cycle or thread states. So now while executing of thread, what are all the states that a thread can be available? What are all the states of a threads? States of a threads means now let's see. So whenever we are starting, whenever just we are created an object, Okay, a thread object is there are multiple states is there. Okay, those are first let's see that there are six states. Okay, new, runnable, blocked, waiting, timed waiting, and terminated. At any point of time, thread will be in any one of the state. Okay, a thread will be in any one of the state. Okay, at any point of time. Let's see, class one has a one member of enum called state. Yeah, let's go to thread class. Okay, let's go to thread class. There is a there is a class called state. Yeah, state enum, right? I think it is of enum, maybe enum. Yeah, see, it is there is a idiom called states. This contain all states of a threads. It is of new thread. A thread state for the thread which has not yet started. If you are creating just object of a thread, then in that case it will be in the new state. Okay. Next, runnable state. Okay. Blocked state. Waiting, timed waiting, and terminated. Now let's see all state sheets. Okay, if you want to see of that all the states, then you can simply print off this method. It will give all the states of a thread communication. After this, write this code, it will print. So what I'm doing, thread dot state dot values, it will give all the values. Okay, that I am iterating by using a for each loop. See, new, runnable, blocked, waiting, timed waiting, and terminated. Let's have given off all the some description also for each state. Thread will be new means a thread will be in the state before calling start method. Before calling of start method, the thread will be in the state. Means that means if you are creating object of thread class, then thread will be in the new state. Okay, and next runnable. A thread will be in the state after calling start method. After calling of the start method, it will be in the state is running mode. Okay, now blocked. So when this the thread state will be blocked means a thread will be in the state when a thread is waiting for object to lock, object for lock. So to enter into synchronized method or block. So let's if one thread is already locked by that object, if some other thread is waiting, some other thread is waiting, one is already acquired the lock of that object and some other thread is waiting, that waiting thread state is will call it as a blocked because that object is already locked by some other thread. In that case it will be in blocked state. Okay, now, waiting state. Waiting state means a thread will be in the state whenever you are calling of wait or join method. If you are calling these two methods, then thread will be in the waiting state. But in the above state, even this case also it is in waiting mode, but will not call it as a waiting. It is blocked because of the required object lock for that thread is already acquired by some other thread. Until that is releasing that lock, the the other thread will be in the waiting mode. We'll call it as a blocked state. Next, timed waiting. Okay, there are some methods. Okay, in join and wait, there are some methods. If you want to keep a thread will be on particular period of time, particular period of time, if your thread want to be keep in the waiting mode. Okay, thread want to keep in waiting mode, then in that case, then in that case, see, we have a wait method is there. So until someone has to notify it, or else wait of long timeout. Okay, wait of, we need to give off timeout milliseconds. Let's say give off 10 milliseconds. 10 milliseconds. Then what it will do, we no need to notify of this one. So after some period of time, after 10 milliseconds, automatically it will be resumed back. Automatically it will be resumed back to running state. It will not wait more than 10 milliseconds. Within 10 milliseconds, it is finished off its calculation. Let's give only 1 millisecond and increase of 1 to 10,000. 1 to 10,000. Sum of 1 to 10,000. This is the sum of 1 to 10,000. Okay. Don't call off notify method, and I'm giving off only 1 nanosecond, 1 millisecond. Let's see. Within second, within millisecond, it is finishing off its task. Let's calculate off. Let's try this. That will finish off. It is finishing its task within millisecond. Okay, within millisecond it is finishing. So if it is not finishing also, it will come out of that. Okay, here no need to notify that. So a timed waiting we are doing. So only for 1 millisecond it will wait for the thread to finish off its calculation, and then so if it is not finishing also, doesn't matter, it will take the control back again. That's what this waited timed waiting. Okay, a thread will be in the state when a thread is in sleeping, and a thread will be in the state when sleep or wait with the timed waiting, with the timeout. We'll give off some timeout. Okay, how much time a thread will be in the sleep mode or wait mode or in join. Okay, now next terminated. Once a thread will be in the state once finishes execution, then at the end the thread will be in the terminated state. Okay, this is a example diagram. New, it is in starting mode. Okay, and next if you are calling of start method, it will be in the running mode. Okay, now it is in running mode. Now blocked, when deadlock occurs, it will be in the blocked. Okay, it is waiting for the thread. And timed waiting, timed waiting means sleeping off with some time. We are giving up sleeping off some timed waiting. So how much time it has to wait? Okay, either this one or wait method, we can call off with some timeout. Then in that case it will be in the timed waiting. If you are calling without any time, either wait or join method. If you are calling without any time, then in that case it will be in the waiting mode. Okay, once it finish of its execution, then it will be in the terminated mode. So once the thread is completed its task, then the thread will be in the terminated state or dead state. Okay, this is what the states. Okay, next multi-threading enhancements. Is it up to now clear, guys? If any doubt is there, just ask me, we'll revise it before going to enhancements. This is of again entirely different. We will not use of thread. Okay, we'll use of callable interface instead of runnable. We'll use of callable interface. Entirely it is of different things. Okay, so till now if you have any doubts, you can ask me, guys. I'll repeat it, this part. If not, then multi-threading enhancement we'll discuss in the tomorrow's class. Okay, it is of callable part. Again, it is not, will not use, till now we are using of creating thread by using either by extending of thread class or by implementing runnable interface. But here it is totally different interface is there, that will call it as a runnable interface. Okay, internally we have a method called call method. Internally we have a method called call method, that we'll discuss. Even we can use of a thread also, but we have a method called other option also, the callable, that we'll discuss in the tomorrow's class. Okay, guys, that's what for today's class. We'll meet tomorrow. Thank you, guys.